Okay, so now we're going to be talking about some math. So to introduce you to the math concepts around local anesthesia, the first thing you need to be aware of, within some cartridges, there are two drugs, the lidocaine, the amide drug, and the epinephrine, the vasoconstrictor. Not all amides, such as like mepivacaine, have a vasoconstrictor. So occasionally you only have to concentrate on one drug, the amide. Sometimes you have to concentrate on getting both equations for the vasoconstrictor and the amide drug that's within the cartridge. So what we'll be talking about today is how to calculate safe drug doses, what maximum recommended doses are for the drugs that you'll be delivering in local anesthesia, and also to know that these maximum recommended doses have been raised significantly. So in your pharm textbook, they may be incorrect. Currently, the FDA has raised up a lot of the doses, so I'm going to stay focused not to be giving you the wrong numbers. It's all right now on the PowerPoint, but bear with me if I say the wrong thing. I will correct myself. The other thing that we'll be talking about is the limiting drug. So when you have a cartridge that has the amide drug, such as lidocaine and the epinephrine, one of those drugs will reach its maximum recommended dose first. So sometimes you figure out the lidocaine and it will say, oh, you can give 13 cartridges to this healthy patient. Oh, but wait, there's epinephrine in there as well. And the epinephrine is nowhere near 13 cartridges. You can only deliver 11 cartridges. So in that regard, the epinephrine would be the limiting drug because you always default to the drug that has the lower maximum recommended dose. And then we'll talk about dose modifications. And you want to modify doses when you have a cardiovascular patient, when you have a patient with a slight frame, and also patients on either end of the spectrum of life, the very young and the very old, or ill as well. All right. So what is the maximum recommended dose? So it represents the maximum quantity of a drug that can be safely administered during an appointment in most situations. So it's usually based on, most of the time you will get two numbers, based on the weight of a healthy 150 to 160 pound person or an absolute maximum. The MRD will be less for children, someone that has a smaller frame, or one that is medically compromised. So the MRDs for injectable dental anesthetics, so for 2 and 3% mepivacaine, you're allowed to give 3 milligrams of mepivacaine per pound with an absolute maximum recommended dose of 400 milligrams. 2% lidocaine is 3.2 milligrams per pound with an absolute MRD of 500 milligrams. 4% prilocaine is 4 milligrams per pound with an absolute of 600 milligrams. Articaine, 4% articaine is 3.2 milligram per pound. Absolute, they don't have an absolute, but usually they will use the weight-based MRD. And then bupivacaine, 0.5% bupivacaine only has an absolute MRD of 90 milligrams. So factors required for dose calculations. So with local anesthetics, the concentration is expressed as a percentage. So in the last slide you saw we have 2% lidocaine, 3% mepivacaine, 4% prilocaine. So they're expressed as a percentage. And volumes and doses delivered, we'll talk about milliliters of solution. Remember, liters like a 2 liter of Coke? That's a liquid, so that's the solution. And then the milligram is the drug. So I think of that like solution milliliters as the Coke bottle, the milligram when I'm turning it over, how much sugar is in this, right? You're looking for the grams of sugar in milligrams. So the milligrams is the drug, the local anesthetic drug that's dissolved in the solution, which is water. And you also need to know the drug's MRD. So here are the percentages that are expressed: 0.5% bupivacaine, 2% lidocaine, 3% mepivacaine, 4% prilocaine, and let me add here 4% articaine. So here are some common dental concentrations. Let's focus our mind here. 2%. Because the 2% solution, we're most of the time talking about lidocaine. So this is a big one we do all the time, the 2%. So what does 2% mean? 2% means 2 grams of something, 2 grams of lidocaine for every 100 milliliters of water. 2%, like if something is 2% sugar, it also means 2 grams of sugar in 100 milliliters of water. That's just what 2% means. So 2% equals 2 grams over 100 milliliters. So we want to sort of condense this a little bit. So we create the milligram equation. We convert, the 2 grams into 2,000 milligrams. So 2,000 milligrams is the same thing as saying 2 grams, still over 100 milliliters. And I'm not sure, I hope some of you learned this in math. So when something is below something in an equation, you can cross off 2 zeros here and cross off 2 zeros here. Actually, not crossing them off, but imagine you're crossing them out, and then it equals 20 milligrams per 1 milliliter. So this is the piece I want you to know. This is how we get there. I want you to know that 2% solution means there's 20 milligrams of something in every 1 milliliter. So for our purposes, 2% lidocaine solution means that there's 20 milligrams in every 1 milliliter of water. But unfortunately, our math does not stop there. Well, this is just saying. So this shows you how it goes from 0.5%. So I want you to know that's 5 milligrams per 1 milliliter, 2% is 20 milligrams per 1 milliliter, 3% is 30 milligrams per 1 milliliter, and 4% is 40 milligrams per 1 milliliter. However, we don't deliver a cartridge. A local anesthetic cartridge is not 1 milliliter. It is either 1.8 or 1.7. So you need to know both of these numbers, and it will be given to you in any equation. I will say it's a 1.8 milliliter cartridge or a 1.7 milliliter cartridge. So when we have that 2% solution, which we've discussed means it's 20 milligrams per 1 milliliter, you will take that 2%, that 20 milligrams per 1 milliliter, you will times it by 1.8 milliliters per cartridge because that's the cartridge that you're given. And what you get is 36 milligrams per cartridge. So when we have 20 milligrams in 1 milliliter and 1.8 milliliters, that gives us 36 milligrams of lidocaine in one 1.8 milliliter cartridge. Now the same holds true if it's a 1.7 milliliter cartridge. We have a 20 milligram per 1 milliliter. We times it by the 1 or multiply it by the 1.7 milliliter cartridge we have, and then we get 34 milligrams of lidocaine per cartridge. And this is what it looks like for each of the local anesthetic drug percentages that we have. So the 2% solution you get here, you understand that this means 20 milligrams of lidocaine per 1 milliliter of water. And we multiply it by how much the cartridge is that you're delivering. So the milliliters cancel out, right? Milliliters cancel out, and you get 20 times 1.8, and that's 36 milligrams per 1.8 milliliter cartridge. 3% solution means 30 milligrams per 1 milliliter. 1.8 milliliter cartridge, it's 54 milligrams. Now, what if I said to you that the cartridge itself here, what if I said it was 1.7? So then you have to figure out 30 milligrams times the 1.7 milliliter cartridge, which would then give you, 51 milligrams per 1.7 milliliter cartridge. So you have to know the equations based on 1.7 and 1.8, and that number will be given to you in any equation that I give you. Yay, so we know how much is per cartridge. So for the rest of the Camtasia, we're going to be concentrating on a 1.8 milliliter cartridge. So we have 2% lidocaine. That 2%, what does it mean? 20 milligrams per 1 milliliter. We have one cartridge of 1.8. So we have 36 milligrams of lidocaine per one cartridge. Now, the absolute MRD, the tippity top of how much lidocaine you can use is now 500 milligrams. So 500 milligrams, you divide it by 36 milligrams per cartridge. The milligrams cancel out. Change this, and you end up with 13.8 cartridges that you are allowed is the maximum safe dose for this healthy patient. We're going to say the patient weighs about 170 pounds, right? Because 170 pounds, we use the absolute MRD. So 13.8 cartridges is the maximum safe dose for this healthy patient based on the lidocaine. What about a weight-based? Now, let's say the patient weighs less than about 155 pounds. Let's say the patient weighs 100 pounds. So that's a clue to you. This is a very lightly built person, 100 pounds. So we start the same. 2% lidocaine, 20 milligrams per 1 milliliter. One cartridge is 1.8. We get to the 36 milligrams per cartridge. Now we don't use the absolute MRD. We need to look at the weight-based MRD because the person has such a small frame. So the weight-based MRD for lidocaine is 3.2 milligrams per pound. The person weighs 100 pounds, so we times it like this, the pounds cross off, and we get 320 milligrams. So for this 100-pound person, their maximum recommended dose of lidocaine is 320. It's not 500 because they're lightly built. So if you see someone, and it's usually we'll say like 100 pounds, if they're below 155, you're almost always using the weight-based MRD. So for this 100-pound person, 320 milligrams is the total amount of lidocaine that they can receive in one appointment safely. We know there are 36 milligrams in each cartridge, and that comes up to 8.8 cartridges. So 8.8 cartridges is the maximum safe dose for this 100-pound patient. So you have someone like me, I could take the 13.8. You have someone lightly built, you're going to have to use the weight-based MRD. You will be provided both the absolute and the weight-based MRD in any equation I give you. So now you're thinking, well, so if someone's lightly built, we use the weight-based. Well, what if they've got a big frame? Let's look at that. So our 2% lidocaine, that's 36 milligrams a cartridge. The absolute MRD is 500. So that 500 divided by 36, is 13.8 cartridges. Now the weight MRD is 3.2 milligrams per pound. So what if the patient weighs 200 pounds and you're like, I'm using the weight-based MRD? Well, the weight-based MRD with the 200 pounds times 3.2, that gives you a weight-based MRD of 640. But you know that the absolute is 500. So the absolute, the lower number is always the cap. So even for a large person, 200 pounds, 300, 400, 500-pound person, you cannot go above the absolute MRD of 500. So weight-based MRD is usually for lightly built people. You know, other people, you use the absolute. Now, so we get to how many cartridges, like how can we figure out how many milligrams we've delivered if we deliver more than one or we deliver half a cartridge. So here we'll look at it, we're administering multiple cartridges. So you've delivered 2 cartridges of 3% mepivacaine. How many milligrams of mepivacaine did you deliver? So the 3% is 30 milligrams. Per 1 milliliter, the cartridge is 1.8. So we've determined 30 milligrams times 1.8 milliliter cartridge is 54 milligrams of mepivacaine in 1 cartridge. But go back, you've delivered 2. 54 milligrams times 2 cartridges. So when you deliver 2 cartridges of a 3% mepivacaine, you've delivered 108 milligrams of mepivacaine. What if you deliver a half? So we got to this point. We know we have 54 milligrams in 1 cartridge. So if you deliver a half a cartridge, you divide 54 by 2. You don't multiply. You divide by 2 because you use half the cartridge, and you end up with 27 milligrams of mepivacaine that you've delivered when you deliver a half a cartridge of mepivacaine. So that's the local anesthesia drug math. Now we're going to talk about vasoconstrictor doses and MRDs for those, relevant patient factors, standard cartridge volumes, and the dilution ratio for vasoconstrictors. So maximum recommended dosage for vasoconstrictors are based on the health of the patient. So if the patient's super healthy, it's a health-based recommendation. If the patient is a cardiovascular patient, we call it a CV dose, cardiovascular. They have high blood pressure, they've had a heart attack, anything would be considered cardiovascular, like even high blood pressure. So the dilution of the vasoconstrictor is expressed as a ratio. You'll usually see the example is 1 to 100,000. So what does that mean? That means 1 gram of epinephrine per 100,000 milliliters of water. That's 1 to 100,000. That's what it means. So here are our maximum safe dose or maximum recommended dose for vasoconstrictors. The healthy adult, the epinephrine is 0.2 milligrams. In 1 appointment, that's the most that they can receive. And our cardiovascular adult is 1/5 the amount of the healthy adult. So the epinephrine for a cardiovascular patient is 0.04 milligrams. So the drug concentration of vasoconstrictors are expressed as the ratio. So we have 1 to 20,000, 1 to 50,000, 1 to 100,000, 1 to 200,000. Volumes and doses delivered, milliliters of solution, milligrams of drugs. So it was the same example that I gave as the sugar dissolved in the Coke is the drug, the vasoconstrictor drug itself dissolved in the water. And the drug MRD. So drug dose and per cartridge facts. So we're going to concentrate on the epinephrine because this is the most common, 1 to 100,000. So that means 1 gram of epinephrine per 100,000 milliliters of water. So we convert that gram to milligrams. So we get 1,000 milligrams of epi per 100,000 milliliters of water, which then we cross out the 3 zeros here, 3 zeros here, and we get 1 milligram of epi per 100 milliliters of water. And the last step is you then divide the 1 milligram by the 100, and you get 0.01 milligrams of epinephrine per 1 milliliter of water. That's not the last step. Same as the local anesthetic drug. That 1 milliliter, that's not what a cartridge is. So the cartridge, you have to take that 0.01 milligrams of epinephrine over 1 milliliter of water and times it by the cartridge amount, and that's 1.8. So for every cartridge, every 1.8 milliliter cartridge that contains 1 to 100,000 epinephrine, it will contain 0.018 milligrams of epinephrine per cartridge. It's a mouthful. And this is what it looks like, the common dental ratios of what you get per cartridge, going from most concentrated to least concentrated. So when I look at these most concentrated to least concentrated, people get tripped up on this being a bigger number, but the concentration is more dilute because this is more water. So think about it this way. So this is a coffee cup. This is a petite, right? And this is more water, more coffee. This is a small. This is a grande. Maybe that's small. A venti, whatever it is. You know, extra small, small, medium, large coffee. And this one represents the sugar, 1 teaspoon of sugar. So when you put 1 teaspoon of sugar in the extra small coffee, it's going to be much sweeter, much more concentrated than the 1 teaspoon of sugar in a very large cup of coffee. Same thing here. So the 1 to 20,000 is much more concentrated, or you can think sweeter, right? It's like 1 teaspoon of sugar in a very small coffee. So calculating vasoconstrictor drug doses. So we have 2% lidocaine, and almost always it will be combined 2 drugs with a 1 to 100,000 epinephrine. So we've already determined per cartridge, it's a 1.8 milliliter cartridge, that we will have 0.018 milligrams of epinephrine per cartridge. Let me write that here, milligrams of epinephrine per cartridge. The health MRD for epinephrine is 0.2 milligrams, and the cardiovascular MRD is 1/5 the dose at 0.04 milligrams of epinephrine. So we figure out, we divide the MRD, either 0.2 or 0.04 milligrams, by the 0.018 milligrams of epinephrine per cartridge. So in general, when you are delivering 1 to 100,000 epinephrine, based on the epinephrine, a healthy patient can receive 11 cartridges and a cardiovascular patient can receive 2 cartridges. So all these numbers, so what are we looking for? We're looking to figure out the limiting drug. So lidocaine, for a healthy patient, 170 pounds, they can receive 13.8 cartridges. But wait a minute, most of the time lidocaine is mixed with epinephrine. And because of that, these 2 drugs, we look here at this healthy patient, they can't receive 13.8, they can receive 11. So the limiting drug is the epinephrine. If the patient weighs 100 pounds, the lidocaine, they can receive 8.8 cartridges. Still healthy person, 100 pounds, we go down here, wait a minute, the epinephrine says 11. We defer to the lower number, 8.8, right? Then the limiting drug becomes the lidocaine, not the epinephrine. It's the drug that the maximum recommended dosage is reached first. Cardiovascular patient always wins. The epinephrine always wins. Cardiovascular, it's 2 cartridges, that's it. So you might say, 2 cartridges? How am I going to get someone numb with only 2 cartridges? And then we'll talk about this in class. That's when you start to mix different drugs. You might use 2 cartridges of lidocaine with epinephrine, 1 to 100,000, and then you might start using mepivacaine plain, right? So they're not getting any more epinephrine. All right, so that's the math. I know there was some corrections as I was going through it, but that's our math, Cam Tata.